Hi, it's Bobalina, and welcome to Study Journey. Bobalina. Hey guys, and welcome back to Study Journey. It's Mary, and I'm back with another problem of the week, AMC 10 problem, and this is going to be about cubes, and we're going to find the greatest length if you go from each corner of the cube to the other. So, without further ado, let's get on with the video. This is AMC 10A, problem 20 of the year 2010. A fly trapped in a cubicle box with side length 1 meter decides to relieve its boredom by visiting each corner of the box. It will begin and end in the same corner and visit each of the other corners exactly once. To get from a corner to any other corner, it will either fly, crawl, or crawl in a straight line. So what is the maximum possible length in meters of his path? So we know that it is a cubicle box and the side length is 1 meter. And then it has to visit all the corners exactly once. So it can only fly or crawl, but it has to be in a straight line. And then it's asking for the maximum possible length. And here are the answer choices. So we can label all of these as 1 meter. So it has to go from every single one of these corners. And we know that using the Pythagorean theorem, we can figure out that the diagonal of a square with the length of 1 meter would be the square root of 2. So it says it can fly, so it can go from one end to the other like this. So what is that? We had to look at this through a 3D diagram. If this is the diagonal of the cube, then the altitude is this side, which is 1, and then the base would be this side, which is the diagonal of the square, which we know from the top is the square root of 2. So we can find the diagonal of this cube, which is 1 squared plus the square root of 2 squared. So it would be the square root of 1 plus 2, which equals the square root of 3. So this cube, the diagonal of the cube will be the square root of 3. So to write the lengths of the possible ways he could travel from the least to greatest, it would be the square root of 3 is greater than the square root of 2 is greater than 1. So that means if you go from one side straight to the other without traveling diagonal, then it will be 1, which is the smallest. So we want to do this as least as possible. The greatest coefficient of the square root of 3 would be 4, because you can only go like this, this, and this. So 4 times the square root of 3. Then that means you travel to 4 corners. So you have 4 corners left. And those 4 corners, if you want to make it the greatest possible, then it would be the square root of 2. So let's travel the square root of 2 4 times. So it would be 4 times the square root of 2. So the maximum path would be 4 times the square root of 3 plus 4 times the square root of 2. Because remember, the square root of 3 is the greatest and the square root of 2 is greater than 1. So you would want to try to travel these two as much as possible, but the maximum to travel each is 4. You can only travel that length 4 times before it repeats. So this would be your answer. Looking at the answer choices, we can tell that the answer would be D. 4 times the square root of 2 plus 4 times the square root of 3.